Okay, let's talk about the number line. So open circles are like this: an open circle, closed circle, there's a closed circle. That means it's inclusive. So this solution area, 3 is a solution, and -2 is not a solution. There's infinite number of solutions between 3 and -2, all the way up to about -1.99999, etc., but not including -2 there. Then there's this other concept here of bounded. So this is a bounded segment. It has kind of a start and an end. It's bounded on both sides. If you have something that's unbounded, it's going to look like this. On one side or the other, it's going to have an arrow. Interval notation. Some of you might be familiar with interval notation. So the way interval notation works, it has a number, comma, another number. I'm going to put blanks there to represent the numbers. This first number is the lower bound. So lower bound, the second number is the upper bound. It's very important to put the larger number to the right. So in this case, the lower bound would be -2, and the upper bound would be 3. And then you put grouping symbols around for interval notation. And so since this is not included as -2, we use a parentheses to indicate non-inclusive. And at 3, it is inclusive, so we'll use a hard bracket there. So the bracket means it includes the value at 3, and the parentheses means it does not include -2. Finally, inequality notation you might be familiar with. In this case, for a segment, x would be in the middle, so -2, 3, and this, and we have to be careful that's a closed circle, so there would be a line underneath which indicates less than or equal to 3. Let's try another one. So this one has 2 parts to it here. It's a compound inequality. So let's talk about this with interval notation. So that would be from, how low does that one go? That goes to -infinity, comma, -1 is the upper bound, and that's a bracket. And parentheses always for infinity or -infinity. And this right arrow, solution area, would be from 2, comma, positive infinity. Always a parentheses with infinity, and parentheses there at 2 because it does not include 2. If it was inequality notation, we would put an and or here. In this case, it would be an or. So an or in this symbol is union. It's like an or. And then in inequality notation, it would be x less than -1 and x greater than 2. Sorry, that's less than or equal to -1, or x is greater than 2. So that's how you can write these in either interval notation or inequality notation. Let's try this one. So typically the instructions I'll give will be something like graph and find a solution. So graph and find the solution area. Because this is the question given. It's a compound inequality. What I like to do is I like to draw a number line. I just put 2 numbers on there, usually -2, 5, something like that, since those are the 2 numbers in there. And what I like to do is up above, I like to graph both parts. So x is less than 5, I'm going to do in blue. This is an open circle at 5, an arrow to the left. Notice I went all the way to the end of the number line. Don't stop at -2 when you draw the arrow. And then x is greater than or equal to, so a closed circle at -2, an arrow to the right. So I've done each part separately up there. And so what you do for the and statement is both of these things have to be true. So not just the blue line, but also the green line. Well, where are both of those things true? You can visually see the overlap region is right in here. And so it seems to overlap there at -2, but not at 5 because there's no point there at 5. So closed circle at -2, arrow to the right, open circle at 5. The solution would be -2, comma 5, parentheses, bracket. That would be probably the easiest way to write that. try the same problem, but this time let's do the OR statement. This is always a little bit more difficult to do the OR statement with these kinds of problems. So let me draw it again real quickly. I'm not going to go over all the steps here. So x less than 5, open left, x greater than or equal to -2, close to the right. Okay, so for an OR statement, the blue graph, either the number has to be less than 5, so 4, 3, 2, 1, 0, -1, -2, etc. Or the number has to be greater than or equal to -2. So it could be -1, -0, 1, 2, 3, 4, 5, 6, 7, and so forth. So when an OR statement's there, you don't have to have both of them be true at the same time. We know that this is part of the OR solution. That's the AND, the overlap of the two, the intersection. So really any point over here is a solution because it's a solution for the blue graph. Any point over here is a solution there for the green graph. So any value we plug in, if we plugged in 10, well 10 is not smaller than 5, but 10 is bigger than or equal to -2. So 10 is a solution. Really any number you call out would be a solution. So the solution is all reals. If you want to write an interval notation, it would be -infinity to infinity. Math symbols for AND and OR, I think we just did OR and U, and then kind of like an up, down, down horseshoe for AND. Let's switch gears for a second. These are sets of numbers. So A is a set of, looks like consecutive integers, and B is a set of consecutive odd integers. And we're supposed to find the union, or the intersection of the two, which is kind of like an AND statement there, which is kind of strange. So it's kind of like the overlap. Where do these two things overlap? Well, I see a 5 in both sets, and I see a 7 in both sets. So it looks like they overlap a set of numbers 5, 7. Or means, well, anything in B should be included in this solution, and anything in A should be included in this situation, in this solution. So this would be 5, 6, 7, 8, 9, and 11. Notice I didn't have to write the 5 twice. Writing it one time in a set is enough. It'd be kind of redundant to keep writing. Let's go right to these. I think this is where it gets a little tough. So let's graph this one again. So I always like to graph it. In this one, it says graph it. We could also find the solution set, but I'm going to graph a number line. And in this one, I'm going to put just some important numbers like -4 in this problem. Looks like there's a -2, there's a 0, and there's a 2. We got 4 numbers on my number line. So again, up above, I like to go ahead and graph the graph up above of these guys. It helps me with my thinking. From -4 to 0 is that graph. And then from -2 to 2 is the other graph. So this first question asks for the AND, right? That's the overlap of the two, the intersection of the two. So these two intersect right here. So from -2 to 0, and you got it. And on this one, -4, -2, 0, and 2. Again, the -4 to 0, -4 to 0, and then -2, 2. And then we're going to write the OR statement, or the union of the two. So everything on the blue line, everything between -4 and 0 is a solution. Everything between -2 and 2 is a solution. There's a lot of points between those values. So the graph would look like this. Notice at 0 there is a point because 0 is between -2 and 2. Even though it's not between -4 and 0, it's still part of the solution there. So I guess you might say, if you wanted to write the solutions, this one would be -2, 0, parentheses. And this one would be -4, 2, parentheses. So let's try one more example. So again, I'm going to draw the number line. Looks like there's a couple numbers on here, -3 and 4. Up above, I like to graph my thoughts. So this is -3. Well, it starts at -infinity there. So closed circle at -3 goes to -infinity. And this one starts at 4, open circle, and it goes to +infinity. So the intersection of the two is where those two things overlap. Well, there's no solution. They don't overlap at all right there. So there's no intersection of the two ideas. I didn't draw on that one. -3, 4. I'm going to go ahead and graph over here. And so we have these same two, -3 and 4. So on this one, we want to find the OR. So anything over here seems to be a solution. Anything over here seems to be a solution. Only one of them has to be true with an or union there. So I'd say my answer is something like this: closed circle, arrow to the left, open circle, arrow to the right. You could either rewrite the solution is the question in this case, or you could write it this way: x is less than or equal to -3, or x is greater than 4. One last thing, you're going to see some set builder notation. Looks kind of like this in your book. X, the set of all x such that x is greater than 4, or something like that. And it might ask you a question about that. Really, this is the part you want to pay attention to. This set builder notation is kind of old school, very formal math, and oftentimes you're going to see problems where they don't even use the set builder notation. They just say from x is greater than 4. So you want to kind of focus in on what's after the such that vertical line there. That's going to be your inequality, and that should help you on your homework.